Hey DS staff, it's Chris Weber and Anthony Claypool with you again, and we're going to talk about lesson planning a day's lesson, and executing that lesson during today's little video. You can see I'm on my Google search site. I've logged into Distinctive Schools, and I'm ready to go. So to get to the website, I click on Sites as we've done before, on iTeacher, and I'm ready to think about a lesson. So we have a document on the left-hand side called Cognitive Lesson Planning. Let's click on that. It's on our left sidebar. And we're going to review this real quickly and then look at some other resources that we have for y'all. Before we get started, there's a couple of questions that are probably on people's minds. The first is, do you have to use this lesson planning format? And the answer is no. Or do you have to write lessons in this fashion for your sites, for your team leads? And the answer to that is that depends on what your school decides and what your team leads discuss with y'all. So why do we have these lesson planning guides? Well, because what is a non-negotiable for all of us always is that kids are interactively engaged in lessons. That we are explicitly modeling for folks, for our kids, I should say, what they need to learn, that they're participative, that there are multiple opportunities for us to check for kids' emerging understandings and provide immediate specific corrective feedback. What I'm showing you here is certainly the most research-based lesson plan that exists. It's the Madeline Hunter model, it's the gradual release of responsibility model, it's the explicit direct instruction or EDI model. If you're familiar with research on effective school practices, for example, through John Hattie, Hattie, this is an incredibly effective way of teaching. There are other effective ways of teaching that are less directed. And that's fine. Again, the keys are we want all of our kids to learn, we want them to be engaged and interactive in problem solving and the other things that I've already mentioned. So let's go through this lesson plan number by number and see what's there. The first step, identify a focused objective, a skill or target that students can master in the math period. Now, what I find and what I did when I was a teacher is my objectives were too often too broad. So I was trying to teach kids to master more than I really could in 60 minutes or 55 minutes. And that created frustrations for me and them. So a focused objective is our first step. Next, we want to write and or select item types that will represent mastery of that objective. Okay, we're going to use these item types throughout the lesson, as you can see, the different phases of the lesson that we're going to show you in just a moment. Where might you find these item types? Well, I would recommend that you go to IXL. It's a great resource. Now, a disclaimer on IXL, and it's a good problem, but it's still a problem. The problem is there are a lot of different items within IXL. And the reason being is in a given standard, IXL lists problems that are prerequisite to the standard, that are extensions of the standard, that are related to the standard. So we just want to be cautious consumers, me and you, when we're looking at the items to ensure that they actually do directly relate to the standard itself, if in fact that's what we're trying to do. So that's the second step. Identify items that you're going to be utilizing with the kiddos. The next step is that when you identify those items, solve them yourself, you guys. So solve the items and think about how you, as a learner, as a problem solver, go about solving those problems and try to write down steps. Step one, step two, step three, because kids need that initially, in particular, when they're solving problems. That's that heuristic or shortcut type of thing that you're teaching kiddos is going to allow them to problem solve and think critically. But initially, we might take for granted that they internalize these steps, but I think we need to make them very visible and transparent to the kids. So while you're solving several of these problems, Think about what you do. Try to be real thoughtful, real metacognitive, thinking about your thinking, and then transform that thinking into some written steps. And we're going to look at some examples in a moment. You might also anticipate, as it states here, some of the difficulties that kids are going to have. We know these things. Think about multi-digit addition or multi-digit subtraction. When the digit on the bottom in working form is bigger than the digit on the top in a given place value. Instead of regrouping, often our students will just subtract. We'll anticipate those types of mistakes that you know kids make and include those into your modeling. Highlight those and say, why is this incorrect, etc. But do that while you're planning the lesson itself. Next, as we move on down, is to identify vocabulary and prior knowledge that you'll want to activate, that you'll want to tap into. It could be a real-world example. It could be what we did yesterday. It could be what we did last block or last year. But do in the initial parts of the lesson, make those connects explicit. That's brain research 101. That's cognitive science 101. We want to connect new schema to existing schema. So let's go ahead and do that. We know it. Let's do it. And then let's think about differentiation while we're planning this lesson. One way we can differentiate, and we've just listed 4 different ideas here, is by questioning. So we might have different types of questions for different types of kids. Prerequisite questions for kids who require that type of support and more depth and complexity when kids are ready for that. Now you might say, how do I differentiate questioning while randomly selecting kids? And the idea is you can kind of cheat with your random selection. So if you really want to ask Anthony a question and Anthony's readiness levels are not quite where you want them to be ultimately, then you can pick a stick and the stick might say Susie, but you want to ask Anthony a question, say, oh, hey, it's Anthony. But the point is, have ideas of different levels of questions you can ask different of your kids, realizing and recognizing that you want all kids to have access to higher order problem-solving type of thinking. The next idea is modalities. I think a great goal for us, y'all, would be to provide visual, auditory, and kinesthetic instruction in everything we do. Kinesthetic instruction is often known by a strategy called TPR, or Total Physical Response. Let me give you an example. I know you can't see me, but hopefully I'm describing it well enough. Let's say we're introducing a fraction to kids, and it's really going to be important that they understand what the numerator and denominator and fraction bar are called and where they're located within that fraction. So visually, you would draw a fraction itself, and you would draw arrows to the number on the top of the fraction bar, and you would label that numerator and do the same with the denominator. For an auditory, you would obviously state those names, maybe clap the syllables in those longer terms, numerator and denominator, and then point in a real animated way, point to the numerator as you say the numerator, point to the denominator as you say the denominator. For total physical response, you could have the kids stand up or seated or stay seated, but you could say, use your left arm and make a line, a horizontal line. No, that's a vertical line. Make a horizontal line. That represents the fraction bar. Now take your right hand and point to the top of the fraction bar. Point to the space on top of the fraction bar. That's called the numerator. Say and point. Numerator, numerator, numerator. The idea is to really tap into a couple different modalities. The other thing we'd recommend y'all do is choice. When you're assigning problems, give some choice. Maybe ask them to solve 4 of the 6 problems, for example. And then lastly, be prepared to assign different tasks to kids. We know our kids are at different readiness levels, and so assigning them all the same set of problems to solve, let's say for homework, probably not in the best interest of high levels of learning. All right. Well, this is the document y'all can access. It's just a way that y'all can help guide the planning of lessons themselves. Let's go back to the math maps themselves, and let's go to third grade, block 1, and look at an anchor lesson that will give us an idea about what the summer math crew and I have been kind of writing that may represent a lesson y'all want to use. So I'm clicking on the second standards anchor lesson. We've written anchor lessons for every standard in the first several blocks for every grade level. Certainly not enough lessons for all to utilize. That's not the point. The point is to give you all some ideas of ways in which you could write and plan for lessons. I'm experiencing some technical difficulties, so I'm going to go back and try another anchor lesson. Took a while for that one to load, but this one looks to be loading a little bit faster. Here we go. So you can see the format of these lessons is the same for no matter the grade. It says DS Math, grade 3, the standard, and an anchor lesson. Notice the objective. Why do it? And it's in student-friendly language, and it's very concise. Then there's vocabulary identified. Now, you would probably have some chart paper, or on your smart board you would maybe illustrate and have students illustrate in their math journal or notebook where the ones place, 10 place, hundreds place, and thousands place is. And certainly you're going to use this vocabulary throughout the lesson, but just a good reminder that we don't want to skip that important step. We want to connect to some existing knowledge that the kiddos have. So we're rounding today, but you might say in connecting to prior knowledge, hey, this is rounding is something that we're familiar with, but it's used when we're estimating, because sometimes an estimation is sufficient when we're answering math questions. It's a good way of checking our answer. It builds on what we know about place value, but it's a really important skill, rounding. And then you see steps. So when we were earlier talking about metacognitively processing, how do I go about solving this problem? You can see here an idea of the steps that could be associated with rounding numbers, and you might